Today, we are going to discuss the learning outcome, understanding the considerations needed when planning an IT solution. In this session, we'll look at the legal, regulatory, and ethical issues that shape any design, at what really happens when an organization fails to comply, and at how to research and evaluate a more complex solution. There are worked examples throughout to show you how an architect actually reasons through these questions. Here's how the session is put together. We begin with the legal, regulatory, and ethical considerations that sit behind every design decision. Then we look at the real consequences of getting compliance wrong, drawing on documented cases. And finally, we turn to the distinction-level skill of researching and evaluating a genuinely complex solution. Worked examples run all the way through to model the kind of analytical thinking you'll be assessed on. Let's start with a simple truth. A solutions architect never designs in a vacuum. Every decision you make sits inside a legal and ethical context because solutions handle data, real users, and organizational risk. It helps to picture three overlapping lenses on any design. The legal lens is about statutory obligations you must meet. The regulatory lens is about sector and operational rules. And the ethical lens is your professional responsibility that reaches beyond what the law strictly demands. The key point is that compliance has to be built into a design from the start. Treating it as something you bolt on afterwards is itself a design flaw. Data protection law is usually the first legal consideration on the table because it governs how your solution may collect, store, and process personal data. Under the UK GDPR and the Data Protection Act, you need a lawful basis to process personal data, and you're expected to follow principles like data minimization and purpose limitation, collecting only what you genuinely need. Data subjects also have rights, such as the right to access their data or have it erased. A breach happens either when data is processed unlawfully or when it's inadequately secured and ends up exposed. So architects should design data flows that are lawful by default, and a data protection impact assessment is a good way to surface risk early. A closely related issue is unauthorized data collection, because solutions very often gather more data than users realize. Think about cookies and tracking technologies. These need informed consent before they run, and they mustn't quietly collect data beyond what you've disclosed. Silent or default on tracking is one of the most common compliance failures you'll come across. The fix is to build consent mechanisms into the solution rather than bolting them on at the end, and to keep clear documentation of exactly what data you collect and why. Intellectual property is easy to overlook, but IT solutions constantly reuse code, content, and design assets. The Intellectual Property Act protects rights in inventions, designs, and creative works, while the Copyright, Designs, and Patents Act protects things like software code, documentation, and digital content. Reusing third-party code without permission is an infringement, plain and simple. And open source isn't a free-for-all either. Those licenses carry real obligations of their own, so before you incorporate any external component, verify its licensing first. Equality law reminds us that a solution has to be usable and fair for everyone it's meant to serve. The Equality Act prohibits discrimination on protected characteristics, and it applies to digital services just as much as physical ones. This bites in two ways. First, design choices can unintentionally exclude people, poor accessibility being the classic example. Second, automated processes must not produce discriminatory outcomes. The lesson is to assess equality at the design stage, rather than retrofitting it once complaints start arriving. Regulation isn't only about how a solution is built, it also covers how it's used day to day. Health and safety regulation applies to the working environment in which your solution operates, And display screen equipment regulation covers workstation and screen-based work. That becomes relevant whenever your solution changes how staff work at their screens. So an architect should think carefully about the operational context of use and make sure any terms and conditions genuinely reflect these regulatory obligations. Where a solution makes decisions automatically, a further set of obligations kicks in. Users have rights around decisions taken without human involvement, and where an automated decision is significant, you may need to provide a review mechanism so a person can step in. Terms and conditions matter here too. They must clearly and accurately describe how the solution behaves and mustn't misrepresent how data is used or how the system operates. As an architect, flag anywhere automation is replacing human judgment and keep those terms current as the solution evolves. Organizational policy sits right alongside law and regulation as a binding constraint on your design. An acceptable use policy defines what people are permitted to do with organizational systems and data. A bring your own device policy governs the use of personal phones and laptops to access the solution, which raises real questions about security and keeping personal and corporate data separate. Your solution needs to be designed so these policies can actually be enforced, because policy gaps have a habit of surfacing the moment a system goes live. A privacy policy sets out the organization's public commitments, and the solution's actual behavior has to honor them technically. The policy states what data is collected, why and how it's used, and the system must genuinely match that. Where behavior drifts beyond what users expect, perhaps through excessive monitoring or profiling features, you get an invasion of personal privacy. This is why privacy by design is so valuable. Designing with privacy in mind from the outset stops the stated policy and the real behavior from diverging, and any mismatch between the two is itself a compliance failure. Now we move beyond the law into ethics, which asks not just what you're allowed to do, but what you ought to do. 3 principles anchor this. Need to know access means data access is granted only where a person's role and task genuinely justify it, consistent with law, regulation, and company policy. Transparent design means users can understand how the solution behaves rather than being kept in the dark. And accountability means there's clear ownership of how the solution is used, with the architect remaining answerable even for foreseeable misuse. Ethical design also asks, actively, who might be excluded or harmed. Accessibility and inclusivity mean building for the widest practical range of users, not just the typical one. You should also weigh the potential for harm, thinking about how a solution could be misused or cause detriment. And be wary of addictive design features, those patterns in notifications or engagement loops that are deliberately built to exploit user behavior. These are professional judgment calls, not tick box checks, and that's precisely what makes them demanding. Ultimately, the architect carries personal professional responsibility for the ethical outcomes of a design. If a requirement is unethical, you're expected to raise it, and professional codes of conduct reinforce that duty. Take unethical billing as an example, practices like misleading charges or hidden costs. A solution should never be engineered to facilitate them. Ethical practice protects users, the organization, and the wider profession. And it's worth remembering that staying silent about a problem you already know about is itself a decision. Let's draw the 2 strands together. On the legal and regulatory side, you have the UK GDPR and the Data Protection Act, the Intellectual Property Act, the Copyright, Designs and Patents Act, the Equality Act, Health and Safety and Display Screen Equipment Regulation, and the rules on automated decision-making. On the ethical side, you have need-to-know access, transparent and accountable design, accessibility and inclusivity, avoiding harm and addictive patterns, professional responsibility, and fair non-exploitative billing. The legal column tells you what you must do. The ethical column tells you what you should do, even when no one is forcing your hand. Let's make all of this concrete. Imagine a retail organization asks you to design a customer loyalty portal that tracks purchase history and offers personalized discounts. Legally, you'd need a lawful basis before processing that purchase and behavioral data, and cookie consent for any tracking used to personalize offers. On the regulatory side, the terms and conditions must accurately describe how the discount logic works. Ethically, the targeting mustn't exploit vulnerable customer groups, and you'd steer well clear of addictive engagement patterns like manipulative notifications. The whole point of the exercise is that these requirements are addressed at the design stage, not scrambled together after launch. Now, let's look at what happens when compliance fails, because it rarely stays a purely technical problem. It quickly becomes an organizational one. There's reputational damage, as public and media scrutiny follow any disclosed failure. There's loss of consumer trust, with customers disengaging from a solution they see as unsafe or unfair. There's loss of investor confidence, because investors price in the risk of weak governance. And there's loss of market share, as competitors happily pick up the customers who walk away over trust concerns. Failure to comply also lands directly on people and on the balance sheet. Individual developers can face disciplinary action where they're found to have known about a breach. You can see increased staff attrition as skilled people leave organizations they view as poorly governed, and regulators can impose financial penalties for legal and regulatory breaches, which can be substantial. So the fallout reaches both the individuals involved and the organization's finances at the very same time. In the most serious cases, non-compliance threatens the organization's very ability to keep trading. A business can lose its license to operate, which is especially severe in regulated industries. Some breaches, such as serious data protection failures, can lead to criminal proceedings against the company, and personal liability can even extend to individual directors. And in extreme cases, the cumulative reputational, legal, and financial damage is enough to close the business altogether. These are the stakes at the very top end of the scale. Here's a real illustration. The Information Commissioner's Office has taken enforcement action against several UK organisations, including British Airways, after data breaches linked to inadequate security in customer-facing IT systems. Customer data was exposed because the technical safeguards simply weren't strong enough. The legal outcome was enforcement action and a financial penalty from the regulator. The reputational outcome was significant negative media coverage, and customer confidence in how the organisation handled data was badly damaged. The lesson for architects is that security and compliance have to be designed in from the very outset. And notice how a single failure triggered several of those impacts at once. A second case makes the ethical dimension vivid. In the Facebook and Cambridge Analytica affair, widely reported and investigated by regulators, including the ICO, personal data harvested through a third-party application was used well beyond what users had consented to. The core failure was that data was used for purposes people had never agreed to, and there was a clear lack of transparency about how it would be used. The result was sustained public and media criticism, heightened scrutiny of data practices right across the industry, and regulatory investigation and enforcement. The takeaway for architects is that the scope of consent must be respected throughout the entire life cycle of the data. Let's consolidate some key terms. UK GDPR is the UK's data protection law governing lawful processing of personal data. Data minimisation means collecting only the data a stated purpose genuinely requires. An acceptable use policy sets out the permitted use of systems and data. Automated decision-making is a decision made by a system without direct human involvement. A code of conduct is a professional standard of expected ethical behavior. A regulatory penalty is a sanction, often financial, imposed by a regulator for non-compliance. And a license to operate is the formal permission needed to run a business in a regulated sector. Let's pause and check your understanding. Can you name 3 pieces of legislation relevant to designing an IT solution? Can you explain the difference between a legal obligation and an ethical one? Can you give 2 organizational consequences of a compliance failure and say why a single non-compliance event can cause several types of impact at once? And finally, how does privacy by design reduce compliance risk? Have a think about each of these before we move on. For distinction-level work, you're expected to tackle a problem that goes beyond standard functionality, so it's worth being clear about what actually makes a problem more complex. Complexity might come from providing advanced functionality beyond the core solution, from drawing on additional resources such as linked databases, or from giving access to new data that wasn't previously available. It might demand development effort well beyond a standard build, or require integration with APIs or other systems. The common thread is that a complex problem stretches the architecture itself, not just the code you write. When you're addressing that added complexity, your research should be structured rather than opportunistic. Start by defining the additional problem precisely, exactly what new functionality, data, or integration is required. Then identify candidate approaches, whether that's existing patterns, APIs, or architectural components that could apply. Gather evidence for each one, from technical documentation, vendor material, and architectural guidance, and weigh the legal, regulatory, and ethical implications of each candidate as you go. And crucially, record your sources so that your eventual evaluation can be properly justified. Evaluation then means comparing your options against clear, justified criteria rather than gut feel. Look at technical fit. Does the option actually meet the additional functional requirement? Look at integration effort. How well does it sit with your existing systems, databases, and APIs? Look at compliance impact. Does it introduce any new legal, regulatory, or ethical exposure? And look at sustainability. How maintainable and well-supported will it be over the solution's lifetime? A reasoned recommendation should emerge from that comparison, and it should follow the evaluation, never precede it. Let's work an example through. Suppose an organization's core solution handles customer orders, and a more complex requirement now emerges. Integrate with a third-party courier, API, to provide live delivery tracking, drawing on a linked logistics database. The complexity drivers here are clear: a new external API, a linked database, and a new category of data. Your research would review the courier API's documentation and integration patterns, and also the data sharing terms attached to it. You'd then evaluate, say, option A, integrating the API directly into the existing order system, against option B, a separate integration layer that isolates the external dependency. Alongside this, you'd confirm that sharing tracking data has a lawful basis and clear terms, so the final recommendation weighs technical fit, effort, and compliance exposure together. It's worth laying those 2 options side by side. Option A, direct integration, is simpler to build at first, but it couples your system tightly to the external API, makes compliance risk harder to isolate, and means any change to that API hits your core system directly. Option B, an integration layer, takes more development effort up front, but it isolates the external dependency from your core system, lets you apply compliance controls neatly at the boundary, and is far more resilient to future API changes. That trade-off, quick to build versus robust and maintainable, is exactly the kind of reasoned judgment that distinction work rewards. Let's bring learning outcome 3 together. Planning an IT solution means designing for compliance and ethics, not just function. The legal, regulatory, and ethical issues we covered shape every single design decision. Non-compliance produces compounding organizational consequences, as those real cases showed us. And complex problems call for structured research and a justified evaluation of the options. Above all, architects are accountable for the compliance and ethical posture of their designs, and these considerations belong right at the start of the process, embedded early rather than retrofitted.